Okay, good morning. Welcome to
FamilyMath number 96.
FamilyMath number 96. Today we're going to be talking about how heavy is the Earth. And there's a subtle distinction between weight and mass. I'm not going to get into that today.
No.
Okay, you can learn about that when you're older. But this morning you were reading show that up to the camera. You were reading in Foxtrot, and they had a funny joke about how heavy the Earth was, right?
Yeah.
What did they say? How heavy was the Earth?
It said it was 6,588 quintillion tons.
Whoa, 6,588 quintillion tons. So we're going to find out how much the Earth weighs, if the Earth on average, or how heavy it is on average in grams per centimeter cubed. So if we took a little bit of, an average bit of the Earth and made it down into something smaller, not took the whole Earth and smushed it down, but took something that was sort of like the Earth and made it smaller, like the size of a frying pan.
Yeah.
An iron frying pan weighs 8 grams per centimeter cubed. So if we took an average bit of the Earth, you know, rocks and stuff, and made it into a frying pan, would it weigh more or less than the frying pan? And a brick weighs about 2.5 grams per centimeter cubed. So if we made an average bit of the Earth, do you think it would weigh more than a brick, or weigh more than a frying pan, or less?
I think it would weigh more than the frying pan.
You think it would weigh more than a frying pan? What do you think?
I think it would weigh, more than the frying pan.
And water, by the way, weighs 1 gram per centimeter cubed. Okay, you can put those things down now. So I looked on Wikipedia, and I found out that the radius of the Earth is about 6,370 kilometers. And I found that the mass of the Earth is about 6 times 10 to the 24th.
Whoa.
Do you know what that means, by the way? Times 10 to the 24th?
It's a
Oh,
one.
wait. Your brother.
I think it's a 1 with 3 times 24 zeros.
It's a 1 with 24 zeros. So this number is a 6 followed by 24 zeros.
That's a big number.
Whoa.
Yeah, that's called scientific notation. Do you like science?
Yay, I do.
Okay, good. So hey, have we ever talked about the formula for the volume of a sphere?
Not really.
Okay, so the volume is 4/3 pi times the radius cubed. Cubed, yeah. So we're gonna figure some stuff out, but we're gonna use a calculator
So
instead.
it's 4/3 times this.
Okay, so it's first of all it's 4/3 times pi, and what's pi?
3.1415.
Good. So this is about 4, let's call it 4.2 times this cubed. 6370 times 6370 times 6370. And that equals, let's call it 2.6 times 10 to the 11th. And then I gotta times that by 4.2, right?
Mhm.
Okay, so, oh hey, that's about 1 times 10 to the 12th, or 1.1 times 10 to the 12th. Okay, that's pretty cool. So we have the mass divided by the volume in kilometers cubed. Okay, but we need to compare it grams to centimeters cubed. So we got a little work to do still, right?
Well, centimeter. There's 100 centimeters in a meter.
There's 100 centimeters in a meter, and there is no eraser in my hand. You see an eraser anywhere? Right over there, on the shelf. Okay.
And isn't there 1,000 meters in a kilometer?
Yeah, very good. So we have these two numbers, 1.1 times 10 to the 12th kilometers. Oops, that's gonna put the mass on top. Sorry about that. 6 times 10 to the 24th kilograms divided by, what did I say, 1.1 times 10 to the 12th. Let me just do 1 times 10 to the 12th,
Okay.
just to make it easier. 1 times 10 to the 12th kilometers cubed.
Whoa.
Well, we have to figure out how to simplify this. Okay, and we want grams to centimeters cubed. Do you know how many grams are in a kilogram?
1,000.
1,000. So this is going to be this times 1,000 grams, so that's easy. So 6,000 times 10 to the 24th grams. And you said how many, we have to figure out how many centimeters are in a kilometer. Can you tell me how many centimeters are in a meter?
I think that's 100.
100. And how many meters are in a kilometer?
Meter is 1,000.
Okay, so there's 100,000 centimeters in a kilometer.
That's a lot.
That's a lot. That's 10 to the 5th and then we have to cube that. What is 10 to the 5th cubed?
10 to the 15th.
Okay, so we have 10 to the 15th times 10 to the 12th, because it was 1 times 10 to the 12th, centimeters cubed.
Whoa.
Okay?
And the powers add here.
Right. So this turns into, well, 6,000, I can add 3 zeros up there. So it's 6 times 10 to the 27th grams over 10 to the 27th centimeters cubed. And the 10 to the 27th are the same, right?
Yeah.
So this is just 6 grams per centimeter cubed. And remember, we approximated a little bit, so
Yeah.
this isn't 100%, right?
No.
No. But
So
we're actually...
it's less than iron.
It's less than iron, but it's more than a brick. So if you had an average size piece of the earth, it would actually weigh more than this brick if it was the same size as the brick. Feel that brick?
Mm-hmm.
Whoa.
Pretty heavy.
Okay, now...
It'll weigh less.
But it would weigh less than this iron skillet. So feel this.
That's heavier.
If you took an average sized piece of the earth, it would actually weigh more than that. And by the way, it would weigh about 6 times as much as water. Isn't that pretty amazing?
Interesting.
So if you drank a glass of earth instead of a glass of water,
You'd
you'd be like, ugh. Pretty cool, right?
Yeah.
All right, can you go put that back on the stove?
Alright.
All right, good job, guys. That was a good video.